Hello, welcome to MyWebUniversity.com, my website, where I teach you computer science related topics and IT development in English, which is this YouTube channel in English and also in 4C. And English version is right here. I have more than 2.8K of subscriber and 1.7K of videos. I teach computer science topics such as operating system, programming languages, database, networking, and applications, utilities, and software, system automation, and you name it. The scripting, Windows subsystem, Red Hat, Solaris, Linux Ubuntu, Anaconda, Python, Awk, C, C++, MySQL. There's a lot of them. MariaDB, and then also cybersecurity and computer programming as well. So this is about 1.7K of videos. You're welcome to subscribe and join the channel, and then make some nice comments so I can add more and enhance it based on your needs, and make sure that the requirements that you're a developer or maybe a student learning, I could help you out to find a job and everything, so you can enhance your career in the long run and you will achieve your goals. As well as I have the 4C version of my Web University in 4C, which I have a lot of computer science and IT related topics, similar topics that I mentioned earlier, as well as, for example, talking about algorithm, or talking about the Boolean algebra and George Best and De Morgan's law and all this stuff, object-oriented programming, a lot of stuff, whether it's in programming or database or operating system or shell scripting or Python. I have discussed that one, including MySQL shell stuff and that or so on. Then all of that one is in 4C. I hope you enjoy it. What I'm going to do today is going to introduce you to my website first, which I just did on the YouTube channel, also in 4C. There's also this direct path to Linux Ubuntu, where I have my online book that I have about 15 chapters on this book. You can learn the entire Linux Ubuntu online using chapter 1 through chapter 5. Chapter 2 is about basic Linux commands. You can actually practice it using your browser on my cloud. So you just come in on the chapter 2. I provide you a set of tables, about 33 commands, and you can get documentation, manual pages, and PDF and everything here, as well as practice it and get the commands output there. Chapter 3 is intermediate Unix and Linux. Chapter 4 is advanced. Chapter 4 has a lot more than chapter 3. Chapter 2 has 33. Chapter 3 has 33 commands, and then chapter 4 has about 88. For each of these tables that I have the what is section, the man pages, the examples. So you can come in online and practice these ones by clicking the command. You could just see the output. For example, process stream 3.1, you can see the output right here. System D is process ID 1, and then this is the output for process stream 3. Similarly, you can get the manual pages for them, and you can do it, or you just type in the command pwd and then get the manual page for pwd. If you're interested in further than this one, you can also watch my videos for each of these rows. I made one video. So the last row would be chapter 4, part 8 of 2. You will have covered, I have covered G-code through make. So all of this would be part 1 of this video, and part 2 would be this video, and so on. And then you're also welcome to see the shell scripting, which is the next chapter, chapter 5. So you can practice shell scripting. In addition, I have on the main page, you can see the direct path to Linux Ubuntu. In this page I have is a dynamic generation of Linux commands. If you want to just get a Red Hat manual pages, there's 12,000 PDF files here. You can just get them. And each one of them you click on, you will just get the output. Similarly for Rocky, similarly for Ubuntu, similarly for C and C++ header files. However, if you want to get dynamic for something that is not part of the Linux commands, for example, if you want to get, let's say, Python, and you can just do this one on the PDF files also have it, but also I will generate dynamically for you here. You can just get the entire manual pages of Python in PDF. And then if you say this is not enough, it's only 7-page long, that is true. But if you do Control F and search for HTTPS, then I take you to the URL on the website. So the entire internet is at your fingertips. So let's say you go to python.org website, I take you to their website, and then you can see that their documentation, all of this information is available to you, and tutorials and everything. And similarly, if you say, can I do the same thing for Java or C? Yes, you can do Java, for example, and then you get the Java documentation. Similarly, you can get the, let's say, Go language, Go build, and then you can get the Go build, and then by going to HTTPS searching for it, you get to golang.org, and then from there you can see their documentation. All of them are online. And then docs here, and then Go specification, Go user manual, and so on. So at the same time, if you're looking for something like Ruby or Python or Perl, you just type in Ruby here. I just generated PDF file for you here. And notice how easy it is to just get the documentation you want. And if you say, how about GCC, GNU collection compilers? Yeah, you could do that one, and I just generated for you here. Notice this one is about 399 pages. But also you could say, search for HTTPS. There's a lot of documentation on the internet that you could go to their website and just go see standard for GCC and so on. All of these ones, or C90, for example, they read the documentation. These are C collection, GNU C collection compilers. Similarly, if you say, for example, how about Docker? You could just look at the docker.pdf, and here's the documentation for Docker. Or something like Podman, which is also for Docker related and this. So I have the resources for you, whether you want it on Linux or you want it on Windows or PowerShell. A lot of my website here, I have generated a lot of documentation. If you are looking at this page, for example, just go into one of these chapter 3, you see these commands. And if you say, well, change mode, I want to learn the security of it, because I don't want people to run the command on my server due to security issues. I just write you like a book documentation so you can go browse through it and understand it, all the command, you can practice it. At the same time, if you want to say, well, that is good, can I practice the command on the server? If it is not a security issue, you can run it, yes. Like df-h, it's give you a -h for human readable, and it gives you the output here. So, and then here you can also run the command yourself. You could say, give me the date command, for example, df. Let me just go to the other chapter, because on this one, maybe I didn't program it that way. So I could just go to chapter 5, and then this section where I have it, I provided an interface for you to practice the command. So if you type in pwd, it gives you the print working directory command. If you type in date, it will run the date, current date. It's dynamically generated on the system. Like uname-a, you can practice Linux on my server using your browser. So the output will be displayed here. ls-l, you get the output. Calendar, you get the output. Calendar 19070, you get the output. But for the security reason, if you say change mode, I provided the documentation. You say, make everybody that has the CGI files with the zero permission, not making executable, then I say, no, you're not allowed to run this command. So if you say rm minus rf slash and wipe out everything, I say, no, you're not allowed to this one. There are certain commands, yeah, I could allow certain one. You cannot just add user add XYZ, whatever it is. So some of the commands you could write pwd followed by some extra garbage stuff, and I will just read that one dynamically, say this is not allowed on my system. And then I also provide the documentation page that if you're just running about change mode or something or change ownership, so just copy that one, put it on the browser here and say, okay, I'm getting a list of them in Ubuntu. Then you can say Control F, change mode, and search for change mode. Control F, change mode, and then change mode will show up, and then you click on it, and then I take you the PDF for Ubuntu documentation. Similarly, if you do something else, obviously, whatever command is there. If you're interested on some command like list X attribute there, just click on it and it will generate the PDF file for you on the fly. So this is about documentation, but this video is not about that one. This video is about Docker. So I'm going to introduce you to Docker now, and I will just go through this video. Without further ado, let's get started with this video. So slideshow, I'm going to just go to a slideshow from the very first slide. And this is a Windows Docker, how to comprehensive guide. So I'm going to show you how to master Docker on Windows with practical insight, which is these Docker containers that are there, these images that holds a container. We're going to just deploy them and we're going to install them and we're going to run them and we're going to just make them a process on the system and so on. But an agenda overview is introduction to Docker. So we're going to introduce you to what is Docker, setting up a Docker on Windows. On each platform, whether you do it on Windows, Linux, Mac, you have to follow up the operating system software guidelines. So there's certain specific things that you have to do on Windows versus Linux Ubuntu versus Linux Red Hat versus Mac Unix. Mac OS X is based on Darwin BSD version, so that's called Unix. And then everything else that we have, whether it's Red Hat, Fedora distribution, or Linux Fedora Rocky version, or Linux old version of CentOS, or CentOS stands for Community Enterprise Edition of Operating System, which was replaced by Docker, by Rocky. And Docker runs on all of them, on all Windows platform, Linux platform, whether it's Linux Ubuntu or Linux Red Hat or Fedora or any other distribution. They do support the Docker images and containers. And then containers basically running as a template of a process as a Docker image. And I'm going to explain all those buzzwords for you so you're not confused what is an image, what is a container, what is a process, and so on. Basic Docker commands, I'm going to introduce you to the basic Docker commands, and I'm going to just run some of those commands and show you actually on the Windows desktop for Docker desktop. Building and deploying application, how you build and deploy application, advanced Docker usage, we're going to discuss that, and introduction to Docker. So what is Docker? Docker is an open source platform. Docker is an open source platform that simplifies and automates application deployment using container technology. So a Docker image, let's say this one is a Docker image. Inside of this image, it has a name, it has an instance, it might have the file system, environment variables, some kind of base image that you're installing, whether you have Ubuntu, whether you have Nginx, or whatever you have inside here. This would be your image, and when you pull it from Docker repository, or whether it's from GitHub or some other place from a user repository that had pushed it in the past to Docker images, then you pull it, and then at the time that you run it, that becomes a container. So you create a container, and that container, you stop it, start it, and look at the logs of it, look at the information, inspect the properties of it. All of that one is in the container, but I'm going to explain that one. So Docker is open source platform that is for easy deployment of application. Application containers. A container, as I mentioned, is just a running process of an image. Containers encapsulate application along with their dependency, provided a consistent environment for development and production. So there are some dependencies of these applications. When you're running an image, you're going to deploy this application with all their dependencies into the running operating system. If it's Windows, obviously the kernel is shared. So the Docker is a smaller image that you have it. So the deployment and stop and start and running it is much faster. Because compared to a virtual machine comes with its own kernel. So if you install a Linux Ubuntu virtual machine, now your kernel contains the Linux Ubuntu. If you do a Red Hat or Sun Solaris or any other Windows kernel, those virtual machine has this one. But Docker runs on top of the virtual machine. The virtual machine is the kernel is shared. It is not each VM consists a virtual machine kernel, and that is depending on what kernel you installed it, Ubuntu, Red Hat, or Rocky, versus Docker running either on Windows or running on Linux. The kernel is shared. Consistency across environment. This is very good for deployment. So you are just writing these images, and then you push it to the Docker Hub, and then people pull it. And now you know that next time when you go from machine A to machine B, the Docker image is going to be consistent behavior. Not that it worked for machine A, now it's not working on machine B. This is very good with consistent environment deployment. And the deployment is minimized very fast, efficient. Benefit of using Docker, increased efficiency. Obviously, the smaller the Docker image, that much faster to load, because it does not have, it is lightweight containers, we call it, and it does not have the kernel is shared. Simplified application management. Simplified application management is Docker simplifies application management by enabling easy deployment, scaling and updating application containers. So that's easy. Isolated environment, and then it's isolated environment where Docker application can run an isolated environment, reducing conflicts and enhancing reliability across different platforms. So if you do it on a Linux platforms, those apps that you do it is basically built for the Linux platform. Once you load the Ubuntu, it is isolated from Linux, maybe another Nginx or something. Each container itself is independent of other ones. So enhanced team collaboration. Docker improves collaboration between the development team and operation, and makes it easy for everybody. Key concept and terminology. This is very important page. Containers. What are containers? Containers are basically the lightweight, standalone, and executable software package that includes everything needed to run an application. So you put an application as a package. That package contains all the software, including the dependencies, but it's very lightweight because it does not have the kernel. And then when you have this container, when you make it, you use Docker build with the tag name, and then you just created a Docker build space -t, and then give a tag name, and then just name it your image, whether you call it Nginx or Node.js or Python something, or any name that you name that application, you could push it into GitHub of Docker, and then that will become there. Obviously, on GitHub, you have to have an account in order to push these images. But once you have that image pushed on the GitHub repository, people could pull from that image. That image is a read-only template. So you write it once and you push it into the GitHub, then this image is available for others to use. When they pull it, this image gets downloaded with the Docker pull command or Docker run command. You get it downloaded, and then after it gets downloaded, now you can just run it. By running it, and becomes a process, which I show you later. Then that process is called a container. The container itself is that process that you can stop, start, and everything. And there's also a Docker file. Docker file is very, very useful for faster deployment. You write a script and name the file a Docker file. You use Docker build command with -t, and then the tag name, and then dot on the current directory where Docker file is. And then this Docker file is read, and this loads the base image. You're having syntax like from node, or from whatever Ubuntu, the colon latest, or Ubuntu version 22, 24, whichever one version you want to do it, you do it. And there's copy command, there's command commands. There's a lot of commands inside Docker file itself that you could just run, and then by running Docker build, it reads this file and then builds the image for you. So this image file that you have, you can use Docker file to build it. And also through Swarm, you can also do YAML files to just do multiple application with containers, multi-containers there. Registries, basically that is a Docker repository that you're just having it onto the GitHub repository. You're storing this Docker images into the GitHub or Docker hub, and then you just set them up and use it. Setting up Docker on Windows system requirements is very minimum. So if you're running Windows 11, the system requirements already met. But if you're running Windows 10, make sure that you have Windows 10 Pro or Enterprise for Docker installation. And then for all of the Windows subsystem, you also, for all the Windows platform, whether you use 10 or 11, make sure virtualization is enabled, as well as make sure that Windows subsystem for Linux version 2 is enabled. And then there's a syntax that you could go from Docker desktop, you run it just say Windows subsystem less.set version to version 2, and then you're all good to go. However, you need to reboot your machine at one point. So after that, when you enable your machine, now your desktop is installed and you could use it. So let me just go back to that part where I was enabling virtualization. That's what is important. Check the virtualization is enabled on your machine. And that is also a step. I had done that one with Windows subsystem videos, whether I do Kali Linux or Ubuntu or Fedora. I did a lot of videos on those ones, and watch those videos, how to enable Windows subsystem, how to enable virtualization, and how to install VirtualBox, VMs on the VMware. And there's a lot of software that I have done a lot of videos on them. Please watch those videos and you will see all of them instructed for you. Installation process, download Docker installer. So by just going to docker.com or download the Docker for desktop. You're downloading that one and then follow the instruction. It's easy, just click on the executable and follow the instruction. It will just install it for you. The Docker command line engine will be installed, and also the Docker desktop, which is kind of a command line plus the desktop contains the command line interface engine, as well as the Kubernetes. So it is a combination of both. It is very nice. It is very nice tool for Docker desktop. And you can run the Docker desktop on Mac and in Linux as well. So whether you're a graphical user interface, GUI person, or command line, I have this video for you, and I'll show you both. Follow the instruction and then configure your setting, as I mentioned, and then configuration initial setup. Docker desktop and setting up Docker involves initial configuration to ensure compatibility. I already mentioned that one. Performance optimization, integration with development tools is important also. But we want to just do commands as well. So I'm going to show you both. So creating and managing containers. Creating containers. When you create a container, you could use Docker files or YAML files, or just create an image from another image that you could pull and then push it later as your image with modification that you made. Managing containers. So containers, once it's become a process, then you can manage it by stopping and starting, and then checking on the logs of it, checking on the inspect what it is, what is the properties and attributes of it. So many things you can do. Container lifecycle management. So from the very first minute to the last minute, you can manage all the containers. Understanding Docker images. Docker images serves as the foundation blueprint for creating containers, encapsulating application code and dependencies. That's very, very important. So pulling image from Docker Hub. Learn how to pull. So you could use Docker pull command to pull an image, and it gets downloaded on your local machine. Once it is installed, you can run it, and then it becomes a process. Managing local images, I will show you that one, how to manage local images as well. Networking volume. So a Docker, in addition to having just the images and containers, and then there's a network between the containers that you have to do it, which I will show you that one. Also, how to have consistent storage, consistencies within the storage of Docker, that is, and the volumes that you're working with. Building and deploying application. So understanding Docker files. By using Docker file, you can build Docker images and writing Docker images. Once you write the Docker files, you can build it, and then once it is meet your requirements, then you can push it into the GitHub. That become a GitHub image that other people could pull. Multi-stage builds. Smaller image creation. That's what is important about Docker. A Docker image, including the environments and all the dependencies and runtime environments, is very, very small. In terms of security, it is very robust, because the smaller the size, the less you have to worry about all the security aspect of it. Deploying to different environment. So when you build a Docker image, and then know that this Docker image can be consistent across different platforms. When you're deploying it, that's important. Development environment. Deployment Docker application in a development environment allows for rapid integration and testing of features. Testing environment. In the testing environment, Docker application can be validated for functionality and performance before production deployment. Production environment. Deployment to production with Docker ensure that the application run reliably and consistency for end user. That consistency is the storage and volumes and environment variables and everything. File system and ports, everything. Using Docker Compose. Docker Compose is good for multi-containers purpose. And you use the YAML file to just deploy them. The multi-container. Multi-container is basically smaller microservices with application, and then you could just deploy it with one YAML file. Running application. Docker Compose allows you to start, stop, and manage multi-container application with simple command, enhancing productivity. Docker Swarm and orchestration. Cluster management. Docker Swarm enables easy management of clusters of docs. To be honest with you, I'm going to cover more on the Docker desktop today. I'm not going to touch anything with Swarm and orchestration, but that is for scalability and load balancing, and maybe some other day that I cover on Linux platform or multi Swarm or multi-container stuff. I may discuss that one. Monitoring and logging is very important to just look at the logs for efficiency, for different tools that they have for the monitoring you could use to see that the performance of your containers, and then where improvement is needed, you could do that one. So as a conclusion, before I just go to the lab activity of this course or this video, I'm going to just conclude this presentation by just saying knowledge acquisition. The guide has provided you with essential knowledge to effective use of Docker on Windows. You have a solid foundation. Installation process, you have learned how to use the installation process and so on. Advanced usage, and then project readiness. I'm going to not read each line of these ones. I'm going to jump in back to the Docker website. So let's go here, and then I'm going to just type in here, say docker.com. And then by going to docker.com website, you can see here the entire website has a lot of stuff for you that you can just get to use it. So some of the things about it, for example, docker.com, about documentation, there's a lot of documentation here that is very robust, and Docker Engine, Docker Desktop, Docker Build, Docker Cloud. So there's a lot of information here, as you can see here. And you're welcome to just go through manual and guides and this and that. But just going to the Docker website here, and let me just go to the main page rather than Docker, docs.docker.com. I'm going to go to docker.com. And this one, you can see on this page, under the containers, you could see a list of containers and a list of volumes, a list of images. So each one of them you click on, you could also search by the information. You can do a lot of stuff. But at the same time, since I went to Docker Desktop, so you could just go here and say google.com and say Docker Desktop install. If you do for Windows, this one comes in and install Docker Desktop on Windows. This page comes in, and basically it allows you to download the Docker Desktop for Windows x86 64-bit. So I have already downloaded and I have already installed in my system. And I'm just showing you here that there's a Windows subsystem backend, how to enable it. All of that options are here. So you can enable the Windows subsystem after you install it and everything, and then you're set to go. You can see here, like Docker Desktop install, you run the install and then start the process. You can do it through PowerShell or just start wdist. So there's many ways you can just do that step. And then if you do it through the net, you have that option. This documentation is very detailed. You can just walk through based on what you need to do. Once you start the Docker, then you could just connect to it, and then you can just use it. So let me just minimize this window, and minimize right here. This is the desktop. So right here, when you have the Docker, after the installation, this Docker Desktop icon will show up. At the same time, if I just go to the services here, under services, there's a process for under the D section for desktop. So you can see Docker. So let me just go to DO. DO, right here. This one is already in running state. By default, it comes as manual, so you just check it, and then if you just run it with the start command, it will run. And then just right now, it says the stop, so I'm going to say start. It will start the process, and now the process is running. You can see it's running. And then when it is running, this Docker process, when you click on it, right here, you could right click and say, right click. Let me just, somehow it is already open. Yeah. So you could click on open and it will open, and this page comes in here. So notice that this is the front page. You have images, and that at this time I don't have any image pulled from the repository. So the option that I have is that I can go to Docker Hub and say what are the images that are available. If I'm looking for Nginx, I could type in Nginx here, and then I could see a list of Nginx processes there. Let me move this thing. That's fine. So you can see that it's Nginx, all of them are there. If I'm looking for like Node.js stuff, Node, then I could get a search on Node, and then you can see all the containers that are on Node-based images. If I just say Python, I just search for it, and then I get the list of the images there. So this is the easy way to see what is available on GitHub. So if you say Ubuntu, for example, you can see that Ubuntu 24 and the Squid and Bind 9 and so many other ones as the Postgres or database. You can type in for Redis and MySQL, so many other ones are there. So at the same time, if you're looking for like a slim version of Python, you can say, give me the Python dash slim, and then that would give you the image that is for slim. If you could say Python dash, let's say Alpine, and then Alpine, and then, so the name of the objects are there, a lot of them, the distro. So if you just say, I don't have a dash, let's see if there's anything with Alpine, then what is Alpine Linux stuff, and then you can see there's Ruby Alpine, and there's so many other ones, Alpine curl and so on. So how about Red Hat? And one of 24, so there's some images, Red Hat UBI, UB9, UB8, and dash minimal, and so on. Red Hat UB9, micro, so many other ones. So I will make some videos for you on Docker images for those ones. But at this time, since I don't have any image, I'm not going to show any containers here. And if I just go on the command line, notice that I also have a terminal here. I can just open a PowerShell terminal and then type in the command here, host name, and then Docker info, and I could get the information here. If I just maximize this window and I say Docker info, that is all the information related to my Docker version. I can get the Docker version information, and I could say Docker images, and then it's no image here. Docker images here, there's no image. Docker image ls, there's no image. But if I say Docker and then run dash d, let's just say run it in detach mode, dash d or dash detach will run it in detach mode. But if I don't put the dash d, it will automatically just run it, and then it's gonna just I have to exit out in order to type in more commands here. That's not good. So I'm gonna show you, like, let's say I'm gonna say the default one, run Nginx here, and then this is gonna go pull the Nginx, and then once it is loaded, and I will have it as an image on my system. But at this time, because I use the detach mode, so the option that is here is running until I open another command here, command terminal, then I could say Docker images, and then now that Nginx is downloaded here. But I could say Docker image ls, and then I could see that this is my container ID. So I could say Docker run Docker exec minus IT, exec mean executed, minus IT, I mean is interactive T for teletype or terminal type. And then I could say this image ID or this image container, and then I could say just run that one. And then if I just do that one, it says I need another argument after that one. So I'm gonna say then bash, let's say, and then it says I don't have that option with it. So what other commands I could have? This is an Nginx. I could say let's just run it rather than execute it because I'm not running it as a process here. If I say Docker PS here, there's one process that is there, but it is says up a minute ago, right? It's a process 80. So I'm going to say Docker stop, and then I'm going to just give this process container name, and then I say stop it. Now I have done that one, Docker PS, it's not there anymore. But if I say Docker PS-8, it showed me what was before running, and it exited 11 seconds ago because I did that Docker stop. So now if I say Docker images, I still have that Docker images. I still have that Docker image. I could just come back here on this session. Notice that this one was exit. So that one is not there. So whether I run this command, Docker images or Docker image ls, then I could just control it here, or I can go it on the GUI. So before I delete it here, I'm going to show you that now, since I did this image, now I have that image here on the graphical interface showing Nginx is there. So I can select here and say delete it, for example. I could do it from the graphical interface, and notice that I had the option to delete it, and before, when it was a container, I had the option of and just basically the container to start it and stop it. So now, since it is stopped, I can start it here. And then I can also delete it if I want to do the container. So then I could also use this terminal, say Docker images, image ls. Now I have that one, and instead of ls, I could say dash digest, and dash digest, and then you can see that the hash code for the container's name information. So you could get that information. And if I do it on the command line that we did earlier, let me just go back to that command line here. I could say Docker image ls and dash digest. This is also gave me the hash code there. So whether you open it even on the command line here, cmd, notice that this is same host name, clear screen Docker info, clear screen with CLS. So I'm going to do it. This is like host name Docker algorithm, and then system info 5 more. You can see I'm running Windows 11 algorithm, Microsoft Windows 11. So I could say clear screen and say Docker info, and then 5 more. Then I could get similar information that I was getting before. The command line engine, the Docker model, the Docker MCP, and all of that is there. At the same time, clear screen Docker version was telling me. So if I just say what version I have, you see this clear screen Docker version 5 more, you can see it is version 28.1.1. So I do have the detail here. At the same time, if I just say, let's just say clear screen and say Docker and then image ls. So I have that container, and I could say let's just start that one, or just run another one. It doesn't matter. Let's say I'm going to create another one from command prompt of DOS. So you can see you have option whether you use PowerShell or Windows command prompt or the GUI. The command work the same way. So Docker, I'm gonna say run dash D, meaning detach, but I'm gonna get a different version of Nginx, for example, or maybe the same version, but I want to run it on a different port rather than port 80 by default. So I'm gonna say Docker run detach, and then minus P port, let's port 5000, my local port to map to port 80 of Nginx, and then I could say dash name. I say my web, and then Nginx is the name of the image that I want to do. So now I did this one, and now if I say Docker image ls, notice that this image came out, and it is there 8 weeks. So now if I say Docker pull dash name my web, let me see what happened there. Docker images image Docker PS. Yeah. So Docker PS, and then I just 28 seconds ago, you just are running it, and I name it my web. So this is running, and notice that it's port 5000 on port 80. So if I just do a curl on this one, right now I have to do on port 5000 in order to get the output. So I say that is there from this command line. I could say curl, and then I could say local host on port 5000, and then that would just return online documentation for Nginx here. You can see here. And if I go to browser here, let me just close this one. And I have already in this one, I'm going to open a browser here, say HTTP colon localhost port 5000. Port 5000, now you see welcome to Nginx, and you're doing this one. At the same time, on the command logs, I could say Docker PS. PS, you could see that this is my image container ID. So I could abbreviate it to 95C, and I still get the information. So I could say Docker logs, and then a 95C. This is basically a short one. As long as you make it unique to this image container, it will give you the information. Now notice that it tells me that on Windows 64 machine, access the Docker on localhost on port 5000, and here's the log of it. So that is telling me that I can use that Docker image there. And then at the same time, I want to just change the port to port 80, for example. So I could say Docker PS, and you can see here that one is running on port 5000. I could say Docker stop, and then this 95C. Now I'm stopping that one. By stopping that one, now if I say Docker PS, it's not showing anymore. But if I say PS-A, it shows that that process was stopped a little bit ago. So I could see that one, it was stopped, my web. So what do I want to do that one? So I want to say Docker run dash D for detach dash P. I'm going to do map up port 80 on localhost back to the Docker Nginx to port 80. So I'm going to say the same way. And this time I'm going to say my web 2, for example. I could name it anything, dash name my web 2 or my Nginx, and then my Nginx. Nginx is the actual image, so I'm going to give that information. Now, Docker PS, you could see that I have the new one called my Nginx. And then now I can refer it to by this name, or I can use that Docker ID, whichever one I want, I could do that one. So now that one is there. Notice that I'm running on port 8080. So if I say Docker inspect, and then my Nginx, so it did not get it by that information, but I'm going to get it by df98. That one is, let's see, Docker, clear screen, Docker PS. So Docker, and then I say inspect, maybe I mistyped inspect somehow. Let me just try the container name. And you can see here, it gives you the information. Since I'm on this command, I could say 5 more, and you can see the ID is there, the created, the path, Nginx, and then if I just am interested to find out what port and other ones, I could just say right here, find/I, and then port information, then I can see that the port number is there. And the host port is port 80, and host port here, so I could also say Docker PS, and then that's showing that port 80 is mapped. Netstat minus AN, you can see clear screen, netstat minus AN, and then find/I, and listen, and then this is all the listens, right? So if I just say, show me the one with 80, and then I say find/I, and the number 80, then you can see that that's, I'm listening to port 80 for that one. And if I say curl localhost colon 80, it's going to respond. If I do colon 5000 or whatever earlier that I had done, it's not going to return. No, or 555, whatever number was there, that is not the one. But if I just do it with the local host of port 80, it's going to just return here. And at the same time, if I just don't put anything, by default, it is a local host, and it's HTTP, and then that is going to resolve. So you could see that one. And then also on the graphical interface here, on the page that I search here, and you see that 5,000, it was up. Now, if I refresh it, it's not up anymore because we switched it to port 80. So if I just switch it to port 80 here, then you can see on localhost column 80, somehow it is mistyped here, automatically transfer. So I'm going to say localhost colon 80. It is going somewhere else. Let me just say HTTP colon/localhost colon 80. Somehow it is, yeah. So you can see it is default is port 80, and it says welcome to this. You can also go on the graphical interface. If you don't like the command prompt here, you can do a PowerShell. You can say Docker PS, and then you see that one, and then you say Docker images ls, then Docker PS, actually Docker Docker logs, and then just look at the logs of df98, and then that would just show all the time that I just went to port 80 and connected to it and everything there. So at the same time, if you just come back on the graphical interface, and let me see on the graphical interface, and then you say, okay, these are the images that I have. Notice that if you want to stop it here, you can stop them here. Now it is not running. And then if you just say delete them, then it will be, that container is gone. Now the images, still something is on the other ones are there. So I could just say, go ahead, delete the older one, which was from port 5000, we can do it. As long as they're actually done from either command line or from the graphical interface, they should be clean here. So right here, I have the option to delete this one. And then if it says it is still not a stop, then I have to stop it first for the container, and you see, make sure that it is stopped, and those I can delete them by clicking here. I don't like the graphical interface for one reason, that sometimes the option, if it is available and it does that one, that's great. If it doesn't do it, the command line is much intuitive and much easier. I am very kind of command line person, but you choose whatever you choose. That's up to you. So right here, like I want to delete that one also, and say delete forever. So now that image is there for the containers is empty. Yeah, I'm gonna delete this one also, delete forever. So I have these volumes. Now the images is still marked here. So if this, yeah, now it went blank, but if it doesn't, you could just go use the command line here. So the command line, whether you use it here or another one, so let's say clear screen, you say Docker images, this is everything that you have locally. If you say images dash A, it's all the images that are out there at the GitHub. Docker image itself, ls, is going to list nothing is there at this time. Docker, I'm going to just say load, and I could do it from this command line here. Say Docker run, and then let's say we get the Ubuntu. I'm gonna say Ubuntu, and then it's gonna go and get the Ubuntu. And notice here under the images, as soon as I got it downloaded, this is showing that it downloaded, the image shows up on the image as Ubuntu available here. And then if I look at the container, this one is this, but it's not running yet. So if I just say run it here on the start, then it is going to just become a process. Then images there, and then the Docker container. So if I clear screen here, clear screen, and say Docker images, image ls, you can see one of the image I have. Docker ps, then it's not loaded. I could say Docker run Ubuntu. I could just say -d for Ubuntu, detach it, and say, or I could say without -d, I could say Ubuntu, and then bash. And now it's going to run that image, and it's going to load it, and then it's going to open the bin bash. But it did not actually do what I wanted to do with Docker PS. You can see it's not there. So I'm going to say Docker exec -it, and then I'm going to say Ubuntu. Let's call it also -d for detach, Ubuntu, and then bin bash. Docker, I'm going to pull it first. It looks like it did not do Docker pull Ubuntu. Okay, and then clear screen, Docker images, ls, and Docker run -d, and detach, and then I'm gonna write the image ID here, this, copy, and then paste that, and then I'm gonna say bin bash. Now Docker PS, and it's not there. Let's do this one. Docker exec, and it's still running it. Docker exec -it, and then dash detach. Okay, I could hardly see my stuff. I'm gonna just do it from this bigger window. Let me just do it from here. So I'm going to CD here, clear screen here, Docker PS, Docker images, image ls. So I have an image here. I'm gonna remove that one, say Docker image rm, and then just remove that. And then since it is not stop, I could say first stop that image, stop, and then no such container. Let's see, RM, it says that image is being used. So I'm gonna dash F for forcing it to remove it. Now it is removed. So now if I say Docker image ls, it's not nothing there. What I could do is say, okay, let me just look at the graphic interface to see there's no image here. Yeah, and there's no volume and there's no container. So I'm going to just use this command line, say Docker, and then I say I run Ubuntu /bin/bash. And then Docker PS Docker right, Docker run dash. This should itself is getting it. Let me see, Docker PS Docker image ls. Okay, 55 and the latest Ubuntu Docker, and then run minus and d, and then this name, and then batch. Okay, so Docker PS. Gonna run it interactively so it doesn't detach. I mean the dash D is detached, but IT Docker PS. Yeah, so that process is now bin bash is becoming a process. I needed this IT for interactive terminal option. Now this process is up 3 seconds ago, and this is bin bash. So I could say Docker exact dash IT dash D, and then the name of this process. I could just give the whole information or just see 44 that's unique enough, and then say and go to bin bash, and then let's see why it did not open it. Let me see, Docker inspect C44. Okay, so this is giving me the information about it. And if I just say Docker exec C44, let's say PS command, yeah, it runs that command that you do ls -l. You can run the command, meaning that that container is up. So if I say Docker PS itself, you can see that the container is enough up and there. I could say Docker this, and instead of this command, I could say bin bash, then it's gonna throw me to bash. But why is it not opening a bash script? And that should open this. So I could say Windows subsystem for Linux, and I'm on the bash here for cat -n etc OS-release, and that's my Ubuntu 24.2, but that's my Windows subsystem. I want to see the Docker stuff. So why? And this one is here is a cat -n etc OS-release, and that is telling me, yeah, it is 24.02 long-term support. So that is the same one. So because I configured Windows subsystem, I could just see that one and there as well. And then if I just look at the contents of some other files, like let's say run the ls-latc directory, you could see all of the files there. And then, for example, if I say give me the x attribute attrib.com file, clear screen, and then say just x attrib stop x store.com file. Let's see why It does that one tail minus 1. So the tail command is not going to work, and then x attrib. Oh, x is uppercase. I forgot what it is. So let's see x attrib .com. Yeah, so that's the file. And if I just see the content of that file, or do a word count minus L, and say that is 22 lines, then I could say, and show me the content of it, cat minus n, or what line numbers, I can do that in syntax, because it does support Apache there. So then if I just do some other ones, it is available there. I showed you how to get into the logs of it, how to inspect it. So now if I say clear screen, and then here say Docker PS, notice that image is there. So I could say Docker inspect, and then I could just type in C4. That's good enough, unique enough. And then notice here, if I say 5 more, that information about the actual JSON kind of format, you can see that it's array of, this is an array, this is a dictionary, and this is a key pair value. All of these data are here, and that when it was started, and all the information that is related to this image and the Docker image. So this is a process at this time on the system. It is just an image of containerized of Ubuntu that is running as a process on this clear screen Docker PS. Is there Docker logs of C4? You can see if there's any logs for it, then you will see that one. But at this time, yeah, there's no logs there. And then Docker, there's a lot of commands with Docker. You can see if you want to tag it and everything. So I'm going to just stop this container now, and then remove it from the command line. So if I say Docker PS, I see that one. I could say Docker stop C44. Now I stopped it. And this one is not a running process anymore. As soon as that command prompts me back saying that it is completed, now I say that one Docker PS, it's not there anymore. But if I say Docker PS -A, you could see that all the process that I just worked on this session are available, that they were exited at some point. You can see all the exit. So if I just say Docker image, then it's Docker image ls, then you can see that image is still loaded on my local machine. If I don't need it anymore, notice on the graphical interface, I did it last time using the graphical interface. I just had it on one of these screens. Let me see which one was it. Right here. So on the images, you can see it is still loaded here, right? Ubuntu right here. But there's no container because I stopped it, right? So on the graphical interface, it shows that one. But if I just go back to the command line and say, okay, now I do have that one, I'm going to remove that one. I'm going to say, and instead of this one, I'm going to say remove B59 there. I don't have to force it when it is not running, but it looks like it is still connected to something, so it must be forced. And then you say -F, now it is forced. Now Docker ls is nothing, and then we have it. And then the graphical interface, we look at the graphical interface, it's also gone under images. So I hope you enjoyed it. I hope you learned something. Please make some comments, and go to our channel, and then subscribe, and introduce it to your friends and loved ones, and make sure by sharing you care about their life and improve their life as well. God bless you all. Take care. Bye-bye.